So this is the reduction of carbonyls with LiAlH4. So the reactant will be carbonyl. It can be a ketone or an aldehyde, and then the reagent will be LiAlH4, and then you will have acid to make the alcohol. So if you have a ketone, you'll see that you make a secondary alcohol. If you have an aldehyde, right, the hydrogen is attached, you'll form a primary alcohol as shown here. So let's go through the mechanism. So the mechanism is just that on your reagent, right, on your reagent, a hydrogen goes and attacks the carbon that's double bonded to the oxygen. So then a hydrogen forms right here. Remember that carbon can't have 5 bonds, so that double bond becomes a lone pair and goes to the oxygen. Then what you do is the acid, right? The acid will come by and then protonate the negative charge on the oxygen, and so it'll become a alcohol. And since it's on a secondary carbon, it'll become a secondary alcohol. The next thing is if we did the same thing with a aldehyde, a hydrogen will come attack this carbon. The double bond will become a lone pair, right? So it'll become a lone pair, and then finally, the proton will come by, protonate the negative charge on the oxygen, and become a alcohol. And notice on this one, since it's attached to only one carbon, it will be a primary alcohol. And notice how I got rid of the hydrogen here. I can also get rid of the hydrogen here too, because hydrogens are always implied, just as right here there's 3 hydrogens, but you don't show it. So you can either write the hydrogens, but usually it's just implied. Now the final overall mechanism would just look like this. It would just be, you can just write your carbonyl and then have your reagent of LiAlH and then your acid. LiAlH is just another way to write this. These two mean the same thing. And then you can add your acid and you would form a alcohol. Since it's a ketone, it would form a secondary alcohol. So I hope that helped, and thanks for watching.